So when we cut the cell into half, the current carrying in it is reduced by half. And since power loss is a factor of 4 of the current, so if the current is reduced by half, the power loss is reduced 4 times. And because of this, there will be less power loss in the module. Also, it enables, because of this change, the hotspot temperature of the module decreases. Hotspots, even if they are created, there is very less chance, because the current is decreased, the formation of hotspot is still, the chances of formation of hotspots will be really less. But let's suppose because of some shading on the module, there's a formation of hotspot. The hotspot temperature will be really less, and because of which the chances of the damage to the module will be really less. Another benefit is that the operating temperature is decreased. And because of the reduction in operating temperature, the efficiency of the module will increase. The overall performance of the module will be increased. Now, since I just said that operating temperature has decreased, the output power will increase because our module performs much better in partial shaded conditions. We will see a video that why our module performs much better in the partial shaded conditions because of the configuration. I'll show you a video that what is the change in the configuration that we have done, that our module is performing much better in partially shaded conditions. And also because of all these technological advances, during high radiation conditions, the performance of our module will be much, much better. Also, we are using split JB technology. Now, what are the advantages of using split junction box? The first thing that comes to my mind is if the junction box is split and it is not at a central location, the metallization required to connect those bypass diodes will be really less, right? So if there is less metallization, eventually there will be less internal resistance the electron will have to face. And if there is less internal resistance, the efficiency of the module will definitely increase. Now, another benefit is that of splitting this junction box into 3 parts is that it still has 3 bypass diodes. The benefit is that, if one bypass diode is getting heated up, if there is a single housing, then this bypass diode will also transfer its heat to another bypass diodes. Now, if there are splitted into 3, if these diodes are splitted into 3 housings, then if one bypass diode is getting heated up, it will not transfer its energy to other bypass diodes, and the overall temperature of the housing will decrease, right? So tests have shown that there is significant reduction in temperature, the heat built up behind the junction in the junction boxes, right? Because of this split technology, so there is something around 15 to 20 degrees Celsius lesser heat generation. So this is one advantages of the split junction box technology. Now, this is the path the current takes in our module, right? This is self-explainable. Not much is required in this thing. I'll show you a video that why using this technology or this type of framework, what are the benefits, right? So this is a video which will make you realize what is the benefit of using our modules. Now, we see that these modules are normal modules. These are not Longi solar modules. They are normal mono modules connected. When these are working in normal conditions, the output current is 8 ampere, for example. Now, when there is shading in the lower half, what happens is that since all these modules are connected into series, the output current from the string will be 0. Now, if you use, instead of these normal modules, if you use Longi solar modules, which is half cut, now, even if there is shading in the lower half, still the current generation from the module will be 4 amperes, which is half of 8 amperes, right? So you'll not lose all the generation from the module, even if there is significant shading in the lower half of the string. I hope this thing is clear. Now, because of all these technological advances, we have received these prestigious awards in 2017, 18, and 19, which was the UV Green Lens Energy Yield Simulation and Outdoor Test Award. Now, these are some PV magazine tests which were conducted on our Longi solar modules, and they clearly depicted that Longi solar modules were having more generation than any other module. Now, this is again one PV magazine test that said that a Longi Perk module had much better generations. They did their tests, and these slides can be shared with you. And so you can do your math and you can see these calculations in a better way. Now we'll quickly move towards the second part, which is the reliable bifacial gain that we offer in our HIMO 4 modules. So we'll first discuss what is a bifacial module and what is the basic design change that we have done in a bifacial cell. So a bifacial module is a cell which is a module which is capable of generating power from the rear end also, from the backside also. It is capable of generating power. And what will be the gain from this change depends on many things actually. It's not that it doesn't depend only on the albedo. It depends on various things like the installation conditions and the designing of the system. So we'll see all these things in coming slides. We'll first focus on the design change that we have done in the bifacial cell. So in the right side, the right image, I'm sorry I have not mentioned in which one is bifacial and which one is normal. In the right side, we have this normal cell image, right? So you see there is a complete metallization on the rear side, right? So no light can enter from the rear side. So what we have changed in bifacial module is that instead of using this rear side complete metallization, we have added local aluminum gate lines. Now you see that it's not completely metallized. It only has aluminum gate lines in the rear end. So there is opening from the rear end also, which will enable the cell to enable the depletion region to get power from the backside too. So this is the basic design change in the bifacial module, right? So the next thing is again bifacial Perk technology design that we have adopted. It has silicon nitride coating as an anti-reflective coating on the top, which prevents it from pollution and decreases the light reflection. And we have soldering pads in the rear side also. We have the silicon nitride anti-reflective coating, aluminum oxide passivation at the rear end, and at the top end also. So this is actually a basic design of the Perk technology. Now, just for your understanding, the mechanism of bifacial energy gain, how we calculate the bifacial energy gain. So energy gain is not only dependent on the module, on the module. It depends on the interrow spacing. What is the albedo? I'll also define what is albedo because somebody asked in the chat box that please define what is albedo. So it depends on albedo, the height of the module or the height of the structure. But again, then we have to optimize our calculation. We have to make our calculations because when we elevate the height of the structure, it has its own financial implications. Also, we have to take care of the irradiation conditions. When we choose the site location, we should also understand that what is the irradiation condition of that particular location. What is the amount of reflected light from the clouds? So this bifacial gain can be simulated with the help of PVSys software, right? So these are some of the design parameters which have their effect on the bifacial gain. One is albedo, one is height, one is the ground coverage ratio, and then the DHI. So before that, I'll explain what is albedo. Albedo is the light which is reflected from the surface of behind the module, the surface which is behind the module, the light which is getting reflected from that surface, right? So the reflection is different for different surfaces, right? So albedo can be defined as the light reflected from the surface divided by the light falling on the surface, right? It's different for different surfaces. Like if we have grass behind the module, then the albedo will be different, because different light reflected from the module will be different. If there is dry sand, the albedo will be different, and similar for new snow. New snow has actually the highest albedo. It is 0.82, right? And red tiles have the albedo of 0.33. Now, bifacial gain, if you see the graph which is right in front of you on the right side, the graph shows that what is the relation between the bifacial gain and the albedo factor. Now, albedo, if we increase the albedo, if there is albedo of 0.2, then there can be a bifacial gain of something around 7%. It depends on various other things. To arrive at this graph, we have kept other things constant, and then we have made this graph. So you can see that at 0.5 albedo, the gain is something around 15%. And in practical applications, I can assure you that the gain that we arrive at from the previous calculations, the actual gain is much higher than that. When we have interacted with various people, or we have seen from our experiences in at various locations, the actual gain that we receive from the bifacial modules is much higher than the one which is calculated by the previous analysis. Next thing is the relation of bifacial gain with the height of the module. Now, if the height of the module is 0.3, the bifacial gain is really less, because not much light is getting reflected back to its surface, its rear surface. And what we have seen is that at 1 meter, if you keep the height of 1 meter of the module, then the bifacial gain normally gets constant. So that means that if you increase the height of the module even after 1 meter, there is no considerable gain in the bifacial gain. Right. So this one is, sorry, I have to hurry up because we are already late. Then the GCR again, if it is reduced, then that means the ground ground required is more. So again, this thing has its own financial application, and the graph in front of you shows that how bifacial energy gain is dependent on the GCR. Another thing is diffused horizontal irradiance. I have already said that in previous slides that you should take care of the site location, but that what is the value of DHI at the particular site. So we have done our calculations for two different DHIs, for 63% and for 31%. And we have calculated that at the various ground albedos, the left graph shows that at like if the DHI is 31%, then at the ground albedo of 0.2, the bifacial gain is something around 8%. And if at DHI, if the DHI is 63% and the ground albedo is 0.8, then there can be a extremely high bifacial gain, which can be something around 32%. So these are the system design parameters. Now we have tried and tested our products at various locations in various conditions, like in Saudi Arabia,